Okay, welcome to Coach O's Pre-Algebra. Today we're talking about simplifying by adding like terms. Well, first of all, you have to know what a like term is, or what like terms are. That's a little better, isn't it? Like terms are two or more terms that have the same variable or variables raised to the same power. That's key. So you're going to have the same variable or variables raised to the same power. So they have to look exactly the same to be alike. And those are the ones you can add together. So down here in 4x plus 3 plus 17x, we have 4x and 17x are the ones that are like terms. Okay, there are like terms. The 3 is just a number, and we can't add that. But if we had another number over here, plus 2, then we would add 4x and 17x and 3 and 2. Now, there's a reason you can add these, and this is the mathematical explanation. And yes, you do need to know this. So, when we have this expression, 3m plus 7 plus 9m, 3m plus 7 plus 9m, I got the blah, blah, blah this morning, we're going to reorganize this so that it's 3m plus 9m plus 7, but we can't just do that without a mathematical reasoning that allows us to do that. Isn't that interesting? That we're doing it and we understand it, but because we're just reorganizing, but we have to have a mathematical reason to do it, and it's called the commutative property of addition. And yes, you need to know this property. And A and B, where A and B stand for different numbers, right? Different terms. If I add A plus B, then I can also say B plus A. It's the same thing. Commutative means I'm just switching two terms. Two things, not three. So here, or if I have A plus B plus C, I can also go A plus C plus B by moving A or C and B by switching places. And that would be like if I was adding numbers like 15 plus 35 plus 10, and I knew that it was easier to go 15 plus 10 before I added 35, or 35 plus 10 and then add the 15, I'm going to make it easier. My processing, what's going to allow me to add those numbers more quickly and to process it faster. So the commutative property is what my brain's doing, and you have to know that. Commutative property of addition allows me to organize my terms. So when we go 3m plus 9m plus 7, and yes, you're going to have to do that for a while, showing that that's called collecting the terms. That's what it's called. It has a connotation attached to it. It's called collecting the terms. So we're reorganizing the expression and rewriting it, where we're grouping the variables together or the terms that are alike together. Well, how do we actually add like terms? Again, you might say, oh, 3m plus 9m, it's 12m squared. No, you don't do it that way, because you don't know what the m is, and you don't make it a square. The m just stays. It's just like if I'm adding apples. The red color doesn't change. If I say, okay, I'm going to organize the red and the green apples, all the red apples go over here, and all the green apples go over here. I may have, when I add up all the red apples, I may have 15 red apples, but the color doesn't change. It's red apples. So it goes 15 red. And over here I might have 22 green apples. I'm adding all the apples and I got 22, but the green apples are still green. I don't have some weird color because I added all the green apples. So it's 22 green and 15 red. This is the same kind of thing. The m's, we don't know what they are in this case, so they have to stay the same. But we can add the 3 and the 9. But what allows us to do it? The distributive property allows us to add the coefficients. What you're going to do is you're going to go backwards, gentlemen, just like we did with the distributive property at the end, where you go one way, you have to go backwards. This is going backwards. What do 3m and 9m have in common? An m. So we take out or factor out the m and we rewrite it using the distributive property, and we get m times the quantity of 3 plus 9 plus 7. When we add inside the parentheses 3 plus 9, we get 12m plus 7. And that's as far as we go. So you notice that I don't get m squared because they have that in common. I just add the 3 and the 9, I take out the m, and I get that. Okay, so you do need to know those things. Those are important. So I want you to try these problems. I want you to pause the video. That's a 3b plus 6 plus 2b. I guess my b's look like my 6's sometimes. So that's 3b plus 6 plus 2b. And then you have d plus 2d squared plus 3 plus 5d squared. And then you have this problem, and you have to draw. Anytime you have anything that's a word problem where you can draw something, draw it and label it. A rectangle has side lengths x plus 2 and 3x plus 1. Write an expression for the perimeter of the rectangle. Pause the video, do the problems. When you're done, start the video and I'll give you the solutions. Welcome back. Let's see how you did. Alright, let me pull this up. Did you get these answers? Yes, you do have to. You can't, right now, I do not want you to go from this problem to the answer. You must collect the terms and rewrite the expression collecting the terms before you answer it. You don't have to do the distributive property, but you need to know how you add like terms. That's a good test question. How do you add like terms? Well, you have to use the commutative property and the distributive property, and then you'd have to show me that. So we grouped them and we got 3b plus 2b, we get 5b plus 6. Over here, the like terms are d squared and d squared. So we're going to rewrite this as d plus 2d squared plus 5d squared plus 3. When we add these, you would have factored out, if you used the distributive property, you would factor out a d squared, and what would be left would be the coefficients of 2 and 5, and you'd add those together and get 7d squared. There's nothing else to add to the d because d and d squared are different, because this exponent is what? 1. If there's no exponent, it's to the first power, and this exponent is 2. These cannot, these cannot be added because this is not the same term as d squared. You got to remember that. Students make a lot of mistakes with that particular problem. Now notice though, I wrote 2 answers. Either one is fine, but it's usually you line up the exponents in descending order. But if you don't, it's okay. If you wrote d plus 7d squared plus 3, that's fine. Or you could write 7d squared plus d plus 3. And what allows us to rewrite it? The commutative property of addition, because we could just switch places with them. It doesn't matter. Now here is the problem with the perimeter. See, I labeled, always draw so you can visualize whenever you have a word problem. It doesn't matter where the x plus 2's go and the 3x plus 1's, except that they have to be opposite of each other because they're the same thing and they're the length and the width of a rectangle. When I do this, notice what I did here. I said that the perimeter equals x plus 2 plus x plus 2 plus 3x plus 1 plus 3x plus 1. You might have had it in a different order. That's okay. But then you had to organize it as x plus 3x plus 3x plus 2 plus 2 plus 1 plus 1. Again, you could have put the 3x's first and then the x's or the numbers first. But notice what I did here. The perimeter, therefore, is 8x plus 6. I added all my like terms in the 2. These are also like terms. These are just numbers. But it doesn't ask, if you go back to the problem, it didn't ask for an equation. It asked for an expression. So I do not put an equal sign and say perimeter equals, because it wants an expression, because we don't know what that x, we don't know what x is. If we don't know what x represents, then we can't tell what the perimeter of that rectangle is. It might represent a series of rectangles, that something changes because of whatever I insert into the land that I'm building for the different acres, right, that I'm putting houses on. So because it asks for an expression, I do not write perimeter equals. I say, oh, that's my phone, sorry. I get all these noises. So I get perimeter, therefore, the expression is 8x plus 6. Okay, now I want you, let's do this one together, because you're going to see more. These, the ones you just did are basic simplifying expressions by adding like terms. You're going to get more stuff like this. So you're going to use the distributive property, and the first thing you have to do, because the x and y are different, they're different terms, is you have to distribute the two. So you're going to get 2x plus 2y, remember? And you use the distributive property is one of the most important properties that you learn. You use that forever in math, constantly. So if you're still a little not sure, the more practice you can do, the better. So then over here, we have to multiply everything inside the parentheses here, so we get 3y plus 3x. We have to collect our terms, and we see that we have these two together, so I'm going to write 2x plus 3x, and then I have 2y and 3y. And now I add the coefficients of these like terms. 2x and 3x, so it becomes 5x plus 5y. And that's my answer. I can't combine these any further, because this is 5x and this is 5y. They're both to the first power, but this variable is an x and this variable is a y, so I can't add them because they're different. Okay, that's your lesson. So what do I want you to do? I want you to do the 2-1, and yes, you must be able to do the 2-1. You have to write down 2 things you've learned, and you have to write down 1 question that you might still have about this material, or something else about this material, about how maybe it's used or something like that. But you must write down the 2-1. That's part of your assignment. Bring in your notes tomorrow, and we'll get going. And you guys have a great evening, and I'll see you tomorrow. Bye-bye.